First lesson in Chapter 1 in the Elementary Statistics course, we will introduce a lot of vocabulary and we will introduce what should be going through our heads when we deal with statistics and statistical analysis. The vocabulary that's going to be presented here is vocabulary that we should be using throughout the entire course. It makes life a lot easier for you and myself to be using this vocabulary. In any walk of life whatsoever, you're going to be using a certain vernacular with anything that you do, whether it's sports related, academic related, work related, anything. You know, you wouldn't go to McDonald's and say, "Oh, give me that big burger with the special sauce and the lettuce and tomato and stuff." No, you say, "I need a Big Mac." So with every walk of life, no matter what it is, we use a certain vernacular, and that's what you need to get used to with this course. Let's first break down what statistics is. It's the study of data and research. You know, it's the actual action of taking what you've gathered and looking at it and see what you can conclude from it. Data is your collection of observations. Anything that you've observed in a particular study. Some examples of types of data would be measurements that you might take, possible genders, and any survey responses that you receive from respondents. The data you collect is from a population. A population is a complete collection of individuals. The word complete is very important there. Depending on your study, you'll deal with either a population, which is very rare, or what we call a sample, which we'll talk about momentarily. A census is a collection of data from every member of a population. You're probably well aware of the fact that the United States holds a census from all of its residents and citizens every 10 years. A sample is a sub-collection of members selected from a population. The method of selection is dependent on what your study is. Sample data has to be collected appropriately anytime you take sample data, and it's usually through random selection, taking people at random, because that's the best way to collect data. You can't really select certain people because then your results would be biased or skewed to a particular result. And that's what's the downfall of a lot of statistics, is that what type of people or what type of clientele are they taking the data from? Very important when you start your statistical analysis are the ethics, or what's right and wrong when dealing with experimentation or analysis in statistics. There's always a right and a wrong with pretty much anything that you do. A lot of times there is a gray area, but with the ethics that go on with statistics, you want to make sure there really is no gray area. Things that you have to think about when you're doing experimentation: you have to make sure that the people that you're experimenting with know exactly what they're dealing with. This is probably more prevalent in medical studies more than anything. They have to know what's coming. They have to know if you get the placebo, nothing's going to happen, but you don't know whether you're going to get the placebo effect or not. Any results that you obtain have to remain confidential for the safety of anybody that's doing what you're asking them to do. And of course, the well-being of anyone that you take always has to take precedence over the benefits to the society that you're dealing with. You can't put someone's health, well-being, even life in danger when you're dealing with a statistical analysis. Statistical thinking, you want to start right away when conducting your own research. You have to somewhat start to take that gray area into consideration. We talked about what's right and wrong, and sometimes there's a gray area. Well, how big is that gray area? And how much do you want to deal with that gray area? The main point of this is, and this is tough coming from someone who's a mathematician, but that all statistical analysis and the acceptance of that statistical analysis isn't done automatically because of the fact that mathematics is present. Mathematics, for the most part, is a very black and white subject. And that's why we have to take into account sometimes the gray area that underlies when you're talking about statistical thinking. Things you have to consider: the context of the data, the source, the method of the sampling that was done, the conclusions that were drawn, and the practical implications to society. We're going to break down each one of those 5 and talk about them individually. The context of the data is extremely important. We're talking about the what, the where, and the why. What do the values gotten in the study represent? What do they mean? Where did they come from? And why was the data collected? What is the purpose of the study that's going on here? Is it simply to do better for society, or is there something else behind it? The context will always affect the statistical analysis that you're going to use in any type of analysis with stats. The source, well, that's pretty much the who. Who's taking it and why are they taking it? Things you have to consider with any source. Are they being objective, or is there an incentive to their data? Are they being biased, or are they being unbiased? Typically, when there's an incentive, there could be the possibility, a very strong possibility, of bias involved. The sampling method. This could quite possibly be the most important of all of them. It can affect your validity of conclusions. If you didn't sample correctly, you could get skewed conclusions, meaning that your result really isn't balanced. Take into account who was sampled and how was it done. Was it done ethically? Was it not done ethically? Was it done quickly, or was it not? Voluntary response samples are when your subject decides to be involved or not. If you decide to get somebody involved, it could lead to biased opinions. Think about it. If you're in the mall and you want to sit there and you want, hey, do you want to do a sample on breakfast cereal? Well, if it's somebody who does eggs every morning, they're probably not going to want to be there. But it's somebody who does breakfast cereal. Let's just say Kellogg's screwed them with the size. They're really upset about the fact that Kellogg's, cut their cereal boxes down by half an ounce. Somebody's going to be pretty upset with that and is going to want to do a survey. Conclusions. You have to make sure the conclusions are stated so that every person that ever reads the study can understand. In other words, layman's terms. You'll hear me often say layman's terms in terms of conclusions. I'll tell you, explain in layman's terms. This is where you can kind of start to get back to regular English language, if you will. You always have to make sure the conclusions are free of opinion, and you have to always look at correlation versus causation. Is there a correlation to the data that you're getting, or is there a cause? Correlation and causation are something that you looked at when you were in integrated algebra in the basic statistics portion. Practical implications to society, they have to include, are the results that you got possible to attain? Is it possible to change? Or is it just going to be too difficult? Possibly to do with ability or possible financial cost? Is it likely that things will change? Maybe, maybe not. And the statistical significance versus practical significance. Sometimes you'll deal with statistical significance being, hey, we got to do this. But practical, again, a lot of times it comes in with financial interdependence. Is it financially sound to make some sort of change? You'll find that often in the medical market. Is there some reason? Is it practical to change? Is it financially sound? Drug companies deal with this kind of stuff all the time. The homework in this section is to read the examples that are involved on pages 2 through 9 to gain a better understanding of the vocabulary. And then do textbook questions on pages 9 and 10. Do numbers 1 to 20 all. The answers don't have to be very involved. They can be pretty quick.